Welcome to Lesson 4.1 of the Grant Architect course and the beginning of Week 4, the Logic Model and Theory of Change. We are now entering Phase 2 of our course, Program Design and Mechanics. This week's theme is visualizing the relationship between resources, actions, and results. The logic model is one of the most powerful tools in grant writing, providing a visual roadmap that shows how your program will create change. Think of the logic model as your program's blueprint, showing exactly how investments become impact. Nearly every major funder requires some form of logic model, making this skill essential for competitive grant applications. By the end of this lesson, you will understand what a logic model is, why funders require them, and the philosophy of reverse engineering program design from desired impact back to required inputs. You will also gain practical strategies for building logic models that clearly communicate your program theory to reviewers and stakeholders. A logic model is a visual representation of how a program works. It shows the logical relationships between the resources you invest, the activities you conduct, and the results you expect to achieve. Think of it as a roadmap or blueprint for your program that makes implicit assumptions explicit and visible. The purpose of a logic model is to demonstrate the logical pathway from investment to impact. It answers the fundamental question every funder asks: if we give you money, what will happen with it and what difference will it make? Logic models typically flow from left to right or top to bottom, showing progression from inputs through outcomes. This visual format allows reviewers to quickly grasp your program theory without reading lengthy narrative descriptions. A well-designed logic model communicates in seconds what might take paragraphs to explain in text. This efficiency makes logic models invaluable tools for busy grant reviewers evaluating many applications. Funders require logic models for several important reasons that benefit both applicants and funders. Clarity is ensured because developing a logic model forces applicants to think through every aspect of program design. You cannot create a coherent logic model without genuinely understanding how your program actually works, which exposes gaps in program thinking early. Accountability is established because logic models create measurable benchmarks for success. The outputs and outcomes you identify become the concrete standards against which your program performance will be evaluated throughout the grant period. Communication is facilitated because a well-designed logic model provides a shared understanding between you and the funder about what the program will do and what it will achieve. Both parties reference the same visual framework. Assessment becomes easier for reviewers who can use logic models to evaluate whether your program design is feasible, logical, and likely to achieve stated outcomes. Reviewers often look at the logic model first to quickly assess program viability before reading detailed narrative sections. Logic models contain 4 core components that we will explore in depth throughout this week, with each component representing a distinct stage in program implementation. Inputs are the resources invested in the program, including funding, staff time, facilities, equipment, technology, and partnerships. These are what you bring to the table before any program activity begins. Activities are what the program actually does with those resources. Training sessions, counseling appointments, outreach events, case management, and direct service delivery are all examples of activities that transform inputs into results. Outputs are the direct products of activities, the countable things that result from your work. Number of people trained, sessions conducted, materials distributed, or screenings completed are outputs. These are your deliverables. Outcomes are the changes that result from the program. These include changes in knowledge, attitudes, skills, behaviors, and ultimately conditions and systems. Outcomes are why the program exists and what funders ultimately care about achieving through their investment. The logic model approach uses reverse engineering philosophy, which differs fundamentally from how many programs are designed in practice. The traditional approach starts with what you can do and hopes for good results. You have staff who can provide counseling, so you provide counseling and hope it helps participants in some way. The logic model approach inverts this thinking completely. You start with the desired impact and work backwards systematically. If you want to reduce teen pregnancy rates in your community, you ask what specific changes must occur for that outcome to happen. Then you ask what activities would cause those changes, and finally, what resources those activities would require to be delivered effectively. The key question driving logic model development is, what must change for this impact to occur? This question is asked repeatedly, working backward from ultimate goals through intermediate steps. The design principle is that every single element serves the ultimate outcome. If an activity does not contribute to outcomes, it should not be in your program or budget. Reading a logic model follows a consistent pattern that becomes intuitive with practice. Left to right flow shows resources flowing into activities, activities producing outputs, and outputs contributing to outcomes. This visual flow represents the progression of your program over time from investment to impact. If-then logic connects each component in a clear causal sequence. If we invest these inputs, then we can conduct these activities. If we conduct these activities, then we will produce these outputs. If we achieve these outputs, then these outcomes will result. This chain of reasoning should be obvious to anyone reviewing your logic model. The causal chain means each step logically leads to the next without unexplained jumps. There should be no gaps where reviewers wonder how you get from one step to another. Every connection should be plausible and supported by program theory or evidence. Arrows in logic models show direction of influence and flow between components. They indicate that one element contributes to or produces another element. The visual connections make the underlying program logic explicit and transparent for all stakeholders. Logic models come in several common formats, and you should use the format that best represents your program while meeting specific funder requirements. Linear flow is the simplest and most common format, showing straight left-to-right progression from inputs to outcomes. This works well for straightforward programs and is often exactly what funders expect and reviewers find easiest to follow. Circular formats incorporate feedback loops showing how outcomes inform future inputs and activities over time. This represents continuous improvement and organizational learning, but can be more complex to present visually and may confuse some reviewers. Nested formats provide multiple levels of detail within each component, allowing you to show both the big picture and specifics. A single activity category might expand to show several specific activities underneath it. This approach handles program complexity while maintaining overview clarity at the top level. Results chain formats emphasize the progression through different levels of outcomes, often distinguishing short-term, intermediate, and long-term results in separate columns. We will use elements of this approach in our detailed discussion of outcomes later this week. The logic model serves as a comprehensive program blueprint with multiple practical uses throughout the grant lifecycle. As a planning tool, it guides program development decisions before you even submit the proposal. When designing a new program, the logic model helps you think through what resources you need, what activities make sense, and what results you should realistically expect. As a communication tool, it explains your program to stakeholders including funders, board members, staff, community partners, and participants themselves. A well-designed logic model conveys the essential program design quickly and clearly to anyone who needs to understand it. As a management tool, it tracks implementation against your original plan. During program operation, you can compare what is actually happening to what the logic model predicted and make adjustments as needed based on real-world experience. As an evaluation tool, it defines what to measure and why. Your outputs and outcomes become your evaluation metrics and performance indicators. The logic model essentially creates your entire evaluation framework, showing evaluators exactly what data they need to collect. Several common mistakes undermine logic model effectiveness, and understanding these pitfalls helps you avoid them. Confusing outputs and outcomes is perhaps the most frequent error that reviewers identify. Outputs count what you did, such as the number of people trained or sessions conducted. Outcomes measure what changed as a result, such as increased knowledge or improved skills. These concepts are fundamentally different and must be clearly distinguished in your logic model. Missing links occur when logical gaps appear between components that are not explained. If activities do not plausibly produce the listed outputs, or outputs do not connect logically to outcomes, the entire logic model fails. Every single step must connect clearly to the next step. Unrealistic leaps claim outcomes that are not plausibly connected to the scale of activities proposed. A single 2-hour workshop cannot realistically produce community-wide behavior change overnight. Outcomes must be proportionate to the scope and intensity of activities you can actually deliver. Too complex logic models try to show everything rather than focusing on essentials. The result is a cluttered diagram that confuses reviewers rather than clarifying your approach. Simplicity and clarity should always guide your design choices. Logic model vocabulary varies across funders and fields, which can cause significant confusion if you are not paying attention. Inputs and resources mean the same thing conceptually. Some funders say inputs, others say resources, and still others may use terms like investments. All of these refer to what you invest in the program before activities begin. Outcomes, results, and impact may be used differently by different funders, so read their definitions carefully. Some funders use outcomes as the umbrella term covering all results. Others clearly distinguish short-term outcomes from long-term impact in their guidelines. Read the Notice of Funding Opportunity carefully to understand how each funder defines and uses these important terms. Activities, strategies, and interventions all describe what the program does with its resources. The terminology differs by field and funder, but the underlying concept is identical. Follow funder language by using terminology directly from the Notice of Funding Opportunity throughout your application. If the funder calls them resources, call them resources in your proposal and logic model. Matching funder vocabulary exactly demonstrates that you read their guidelines carefully and facilitates reviewer understanding of your program. Building your first logic model follows the reverse engineering process we discussed earlier, starting with the end in mind. Step 1 is identifying your ultimate desired impact. What is the big picture change you want to see in your community or target population? Reduced poverty, improved community health, better educational outcomes? This is your North Star that guides all other decisions. Step 2 works backward to identify necessary outcomes. What changes in behavior, knowledge, skills, or conditions must occur to achieve that ultimate impact? These intermediate changes become your outcome categories organized from short-term through long-term. Step 3 determines activities that will produce those outcomes. Given what needs to change in your target population, what specific program activities would cause those changes to happen? Be specific and concrete about what you will actually do with participants. Step 4 identifies resources required for those activities. What funding, staff positions, facilities, partnerships, equipment, and materials do you need to conduct those activities effectively and at sufficient scale? This analysis becomes your inputs list and the foundation of your budget. Logic model development is an iterative process, not a one-time task that you complete once and never revisit. Draft iteratively because first versions are always rough and incomplete. Do not expect perfection on the first attempt or even the third attempt. Create a draft, review it critically, and improve it through multiple iterations until the logic flows clearly. Get feedback by sharing drafts with colleagues and stakeholders who understand your program and community. Others will see gaps and inconsistencies you missed because you are too close to the work. Community partners may have valuable insights about whether your logic is realistic for your specific context and target population. Test logic by challenging each connection for plausibility and asking hard questions. Ask whether each activity really produces those outputs, whether those outputs really lead to those outcomes, and whether there are missing steps in your causal chain. Skeptical questioning from colleagues and experts strengthens logic models significantly. Refine continuously because logic models evolve with program understanding. As you implement programs and learn what works and what does not work in practice, your logic model should update to reflect that learning and improve your program design. Logic models serve specific and important functions within the proposal context that extend beyond just satisfying a requirement. The visual component is often required as a figure within the proposal body or as an appendix document. Check Notice of Funding Opportunity requirements carefully for format specifications, size limitations, and page limit rules. Good graphic design matters significantly for visual clarity and professional presentation. Narrative connection means your project description narrative should match your logic model exactly in every detail. If the logic model shows 3 activities, the narrative should describe exactly 3 activities using the same language. Mismatches between the logic model and narrative suggest careless preparation and raise reviewer concerns. The evaluation framework derives directly from the logic model structure. Your evaluation plan should specify exactly how you will measure each of the outputs and outcomes shown in the logic model. These documents should connect seamlessly without gaps or contradictions. Consistency check means all proposal sections should align perfectly with the logic model. Budget should fund all the inputs shown. Timeline should accommodate all the activities described. Staffing plan should enable implementation of everything promised. The logic model becomes your internal consistency check during proposal development. Here is a practical exercise to apply what you have learned in this lesson to your own work. Step 1. Select a program your organization currently operates or plans to implement in the near future. Choose something you know well enough to think through in substantial detail, ideally a program where you understand both the design and the target population well. Step 2. Identify the ultimate impact you seek from this program over the long term. What is the big picture change you want to create in your community or among your participants? Be specific about who benefits and how their lives or circumstances will be different. Step 3. List 3 changes that must occur to achieve that impact, working backward from your desired results. These intermediate changes are your outcomes. What needs to change in terms of knowledge, behavior, attitudes, skills, or conditions for the ultimate impact to occur? Step 4. Sketch a rough logic model on paper showing the flow from inputs through activities through outputs to your 3 identified outcomes. Do not worry about perfection or beautiful graphics at this stage. This is a first draft to practice the thinking process and identify gaps in your program theory. Let us summarize the key points from this lesson on logic model fundamentals. The logic model purpose is to provide a visual roadmap showing how your program creates change in the lives of participants and communities. It demonstrates the logical connections between investment and impact, helping funders understand and evaluate your program design at a glance. This visual clarity is why virtually every major funder requires logic models. Reverse engineering philosophy starts with desired impact and works backward through each stage of program design. Rather than starting with what you can do and hoping for results, you start with what needs to change and design a program specifically to cause that change. This approach ensures every program element serves your ultimate goals. The core components are inputs, activities, outputs, and outcomes. These 4 elements form the backbone of every logic model, though terminology may vary by funder and field. Understanding how these components connect is essential for effective program design and proposal writing. In our next lesson, we will dive deep into inputs, exploring how to define and describe the resources your program needs. Understanding inputs is essential because they represent the investment that makes everything else possible. We will cover financial, human, physical, and informational inputs in detail,